Welcome to qnawire.
Hi, so over here we have the following reaction: N2 as a gas plus 2 molecules of water as a gas that is going to be in equilibrium with the products, that is 2 hydrogens as a gas plus 2 of NO. We're told that the value for Kp is 1 times 10 to the minus 8, and we're going to apply the small x approximation, given that at this temperature with 10 atmospheres of nitrogen and 23 atmospheres of water vapor, we need to treat this reaction. So in our ice table, this ice table is going to be in terms of pressure instead of the amount of mole or the usual concentrations that you can find. We can clearly see that the limiting reagent is going to be the nitrogen because of the stoichiometric relationship. We know that 10 atmospheres of nitrogen can react with up to 20 atmospheres of water. So let me put the value for Kp up here just to have a little bit more space, 1 times 10 to the minus 8. And now we're going to proceed with our ice table. Since the limiting reagent is nitrogen, we're going to have minus x over here, minus 2x, and we're going to produce 2x of both of the products. Next step is going to be finding the equilibrium concentrations: 10 minus x, 23 minus 2x, 2x, and 2x. So now the only thing that we need to do is go ahead and write down our pressure equilibrium constant, the value for Kp. The Kp is going to be equal to pressure of hydrogen squared times pressure of NO squared divided by pressure of nitrogen times pressure of water squared. This is going to become into 2x squared, 2x squared. These pressures comes from our ice table here and here. And on the denominator, we're going to get 10 minus x times 23 minus 2x squared. So now is going to come our small x approximation. Since we know that the value for Kp is quite small, what that means is that the amount that is going to react is going to be small as well. So the value of x needs to be small. Thus, we can approximate that 10 minus x is going to be approximately equal to 10, and 23 minus 2x can be approximately equal to 23 directly. This condition is going to be satisfied as long as x is going to be lower or equal than 5%, than 10% of 10. So as long as x is lower and equal than 1 atmosphere, this approximation is valid. Otherwise, you're going to need to solve the full equation for x. So with this, our value for Kp now becomes, I'm going to expand here, 2x squared, 4, 2x squared, 4 as well, 4 times 4, 16, times x to the 4, divided by 10 times 23 squared. Solving for x, we get that x to the 4 is going to be equal to 10 times 23 squared times Kp divided by 16. The 1 to the 4 we can get rid of by exponentiating both sides to the 1/4. So this is going to become 10 times 23 squared times 1 times 10 to the minus 8 divided by 16, all of this to the 1/4. After doing these operations, we get x equal to 0.043 atmospheres, but we're asked to round to only one significant digit, which is going to be approximately 0.04 atmospheres. So with that, it would be all. Thank you very much and have a good one.